Hi, my name is Vadims. I'm the head of application department of CENOS, the affordable platform for engineering simulation. We integrate an open source tools into the simulation workflow and provide user-friendly interface for it. In previous videos, we created geometry and a mesh of simple printed circuit board or PCB. You can find the links to that tutorials in the description for this video. In this video, we shall continue the simulation workflow and define the properties and parameters of the simulation, and we shall work in the CENOS user interface. Let us start this time with empty CENOS workflow. Select working directory and continue, and instead of adding Salome, we will just read from file. I will choose a file which I have created before. Click open. Now you have here an option to change base units, and actually if you have created CENOS block and created geometry, you can just continue in the same workflow, but you also have to select the mesh base units. By default it's meters, but I have input everything in millimeters, so I'll choose that one. It is important that you are consistent, so you always input everything in millimeters. Now we have a mesh, and let's add a package. We have GetDP and OpenFOAM, which is coming soon. Here we have solvers, thermal solver, and click on it to see what's inside. Here you have a small viewer which allows you just to check if your input is correct, your input mesh, and if you do not see some surfaces, it means that some of groups were not exported to CENOS, and it means that there was some error in your mesh. You can easily see all the geometry features. So let's start with data input. So this is time. It's transient or steady. For steady, there are no further inputs. For transient, just input your result output frequency. I'll start with, so initial time is 0, end time is 120 seconds, time step, let it be 1 second, and I want the results to be output every 10th time step, every 10th second, so I'll put 10 here. Now let's go to domains. All these domain tabs, they are created from the mesh which you have generated in Salome. So let's start with epoxy. Domain type, yeah, we have two, thermal or thermal rotation. We will only use thermal here because you don't have any rotation. You can also input volumetric heat source, means that heat source will be in the volume. The next is material. You can choose any one of these pre-created. So this one is epoxy. You see here CP, lambda, and rho. But you can also say I want to create custom. By default, it will be named my epoxy one. You can call it epoxy 2, for example, and change any of these. Let's say something like that. And this will be in your, from now on, this will be in your library. If you click save in my library, and this will be usable in any further simulations. So initial conditions, we start with 20, and surface, so this name epoxy surface, this is the one we created in Salome. We can put this convective heat flux 520. Let's go to the copper. As you see, you can use here anything from your library called My Library, or you can input copper. Here I'll leave thermal. Initial conditions is 20 degrees, and again 5 and 20. Solder, everything the same, 20, 5, 20. Now the last is silicon. I'll choose silicon again 20, and now we have two surfaces. Silicon outer surface, it also has this convective heat transfer. For silicon heating surface, we have created a mixed boundary condition, which actually is convective plus fixed heat flux. It means that at any time it has a convective heat flux to the outside, and also at any time it has a fixed heat flux which is coming in from this heating. So it's 5 and 20, and for heat flux, you can put it constant, but you can also put it time dependent. We will say it's piecewise linear. It's depends on time, and let's say we are having 83,000 watts per square meter. So at next point 60, again 83, and from 60 first second we have 0, and 120 we also have 0. So it means that we are heating it for first 60 seconds, and then we turn off the heating. Then we don't have this constant heat flux anymore. Then we have only heat transfer via convective heat flux to the outside. Okay, it's done. Now we have input all the data which are necessary for simulation. We can go back now, and as you see, Salome block is green. That means it's perfectly fine. This is orange. Actually, it's only because it's not connected to post-processing block. The moment everything is green, we can hit run and wait for the results. What I want to say is that now GetDP solver will run. There will be some logging. You see, it's red mesh. It has so many elements. So this is a little bit smaller mesh which I'm using because just to save simulation time. When it will finish working, Power View window will appear automatically, and you will see the results. If the calculation will crash, you will see the message about it. You can go back to logging, clicking it here. At the moment, it's running the simulation. So, thank you. Here was Vadims. We performed PCB thermal calculation in CENOS platform. Please see the following video for post-processing of the data in open source tool called PowerView. And you can find a link for this video and for previous videos in the description to this video. Thank you. Bye.